Hey guys, it's Corey again, and today I'm going to be going over what kind of is the difference, high level, between a GPU and a CPU. We are here on the Amazon AWS page, and they have a little explanation. I was just going to walk through that thing. One of the things to note is, and the reason that we're talking about this is that GPUs, graphical processing units, are key to AI. They're key to ChatGPT, to Bard, Gemini, all the different AIs that are out there, plus Air. So Air requires GPUs in the background. So kind of the overall big picture between GPUs and CPUs is GPU stands for graphical processing unit. CPU stands for central processing unit. The CPU is a more complex general purpose style core. So they generally process things, everything that you're running on your computer, your web servers, all of those things run off of CPUs. They The reason that graphical processors were kind of invented was the CPUs were really complex. Um, they had more complex instruction sets. They had more complex processes to get things done. When you look at what a GPU does, it does a single task to millions of pixels. It does a single task to um, lots and lots of data like pattern matching or setting a color or adjusting something, moving some pixel over a little bit or a whole bunch of pixels or a whole line of pixels or a whole large scale high volume high parallel processes. So this article kind of walks through some of those kinds of concepts. Generally, the core they're running on, it says that, they're running on similar technologies, the GPUs and CPUs. The core in the GPU has fewer commands. They're all intended to be highly parallel. But they're also saying, CPUs initially had a single core, which they did. That's where I started, was a lot of CPUs with a single core. But they now have multi-core, and the GPUs are also apparently multi-core as well. I know that, on a whole system you would have tons of GPUs. So one of the things that you have to do with any of these things with multiple cores is you have to manage the traffic between them. So when you look at the multi-core capabilities of a CPU, you want to do that in have much more complex functions that you're trying to do when you're splitting tasks apart in CPUs, and they're generally more serial in nature. GPUs run a lot more parallel tasks, so your task has to be able to be split apart into lots of parallel execution, no interdependency between the two pieces of the process. So memory, both CPUs and GPUs complete millions of calculations every second, use internal memory to improve processing performance. They also have cache. The cache is something that is kind of like your workspace around you. The stuff that's the closest to you, you use more frequently, and you've got access to that very quickly. And then, so that's level one cache. Level two cache is a little bit further out, and level three is even a little bit further out than that. What's unique about a microprocessor system dealing with cache levels and layers is that it's dynamic what it puts in those things. What goes into those, they automatically kind of gets updated based on the usage. So it's pretty cool. It's like, well, if you want your coffee mug right next to you, then you use it a lot and it just kind of stays right next to you. But if you use something a little less frequently, it's a little further out. So that's the level one, level two, level three cache arrangement. And then there's also a cache manager for that cache control unit. So yeah, this talks about it a little bit here. And so key differences between the CPU and GPU. Of course, the computer graphics is what generated the GPUs, and why they were important was because the CPU got bogged down handling all of that repetitive, constant screen updates. Back in the days when it was just characters, it wasn't that big of a deal. But now that there's a lot of graphics, you've got to really get that offloaded to cores that are very specifically designed to do high speed, repetitive, um, highly parallel tasks. So let's see here. Yeah. So it talks about the function. Server cannot run without a CPU. CPU handles all the tasks required for software to run correctly. GPU, on the other hand, supports the CPU. So it's like a little extension arm of little tiny robots that run out there and do a whole bunch of high-speed tasks. Again, we are breaking the task down into smaller components to finish them in parallel. And that means that those tasks have to be independent to a point. They need to be able to go out there and autonomously do the task necessary and then bring it back together. So there's management on the front end to break the task apart. It goes through the parallel processing and then management on the back end to put it back together, the results. So yeah, let's talk about that. Less powerful. Yeah, GPU cores are less powerful than CPU cores and they have less memory. This one kind of confused me a little bit. It says while CPUs could switch between different instruction sets rapidly, I haven't seen too many switching between instruction sets, but maybe I've had some that are modes. GPU simply takes a high volume of the same instruction and pushes them through at high speed. So they are really good at parallel computing. So, here's an analogy I thought was kind of cool. They talk about the CPU as the head chef of a large restaurant, has to make sure hundreds of burgers get flipped. Even though the head chef could do it personally, it's not the best use of his time. He'd be really slow. It would be, you know, it would take everything else down. So it says all kitchen operations may halt or slow down while the head chef is completing this simple but time-consuming task. To avoid this, a head chef can use junior assistants who flip several burgers in parallel. The GPU is more like the junior assistant with 10 hands who can flip 100 burgers in 10 seconds. So that's really a good point. They're just different tasks. They're really different tasks. But why do we use GPUs? What are we going to use them for? Well, they give some examples here. It is for big data, for large language models, um, the or the AI, for AI processes and so forth. They have come up with this deep learning concept, and it was inspired by the human brain. They recognize complex patterns in pictures, text, sounds, other data, and produce accurate insights and predictions. They're doing this by doing massive parallel processing, basically. We used to talk about that in the day. So the term high performance computing refers to tasks that require very high computing power. Here are some examples: geoscientific simulations, financial simulations, real-time, predictive, retrospective data science applications in medicine, genomics, and drug discovery. So a GPU is a lot better suited for that type of a task, working with large volumes of data, processing large volumes of data and walking through it. There's another one. This is an area that I used to kind of work with these guys, the advanced driver assist systems, ADAS, and then autonomous vehicle systems. So they're using lots of parallel processing, lots of technologies in those things, but they are able to process a lot of information simultaneously, kind of like your brain does when you're seeing things. It goes on to talk about the function. So we'll go over the summary and differences here. Function of the CPU is general computing, more complex instruction set. The GPU is a specialized component for parallel computing. CPU is serial instruction processing. It does have parallel units inside, but generally serial design. And then GPU is designed for parallel processing. The design on the CPU is fewer, more powerful cores, and then GPUs is just tons of cores, but they're less powerful. And CPU is just kind of like what you think, general purpose computing apps and high performance computing on the GPUs. And it goes on to talk about, hey, AWS can support you for whatever you need, CPU and GPU. Of course, you're going to have a CPU on there, but with your GPUs. Anyhow, little insight into that. And that's all I have for today. Thanks.